Hello everyone. This time we will talk about parallel lines and transversals. These are our objectives for today. So we will identify the angle pairs formed by two coplanar lines which are cut by a transversal and derive relationships among angles formed by parallel lines cut by a transversal using measurement and by inductive reasoning. So before we proceed, let us try to recall first the different kinds of lines that we have learned from the previous module. So here, we have parallel lines. When we say parallel lines, they're coplanar. And no matter how we extend these lines in two opposite directions, they will never meet. So for the second figure, we have here intersecting lines. So as long as they have a common point. And finally, these lines are intersecting lines, but what makes them special, the angles being formed here would be a 90-degree angle. So that makes it perpendicular lines. So now, our focus is more on parallel lines. As you can see, when if we try to revisit again the definition of parallel lines, these are coplanar lines in which no matter how you extend them, they will never meet. So by the way, we will be calling this region as interior and this one as exterior. So it's very important to remember that because you will often hear the word interior or the word exterior. So I repeat, the ones inside is interior and the ones outside is exterior. So now, let me give you two possibilities. So it's possible that the lines to be given to you would be parallel lines. But in the ones on the right, it might not look like an intersecting line or intersecting lines because you don't see any common point here. But if you extend it here, you will notice that somehow it will have a common point. So these lines are not parallel. So whether the lines are parallel or the lines are not because they're intersecting lines somehow when you extend them, okay, that would be possible. But in our lesson today, what makes it very special and unique from the previous lesson that we've discussed about angle pairs. This one happens when there's another line that cuts the two lines that we have here on the screen. So sa nakikita ninyo, may insert tayo ng bagong line and it intersects the parallel lines. And that's also possible when the lines are intersecting and then we insert another line. So the lines that we've just inserted are what we call the transversal. So how do we define transversal? So it's actually a line intersecting. So let me just, this is a typo. This is intersecting. It's a line intersecting two or more coplanar lines at different points. So for this one, the different points that we are referring here are these points. So these are the intersecting points of our transversal to the lines given to us originally. So I repeat, the transversal can exist even if the lines that are being cut by the transversal are not parallel. So, when two lines are cut by a transversal, just like this one, it will be able to provide you with different angles. So we'll name each angles as 1, 2, 3, 4, 5, 6, 7, and 8. So these are the angles being formed now. So, from what I've said a while ago, it's very important to identify the interior part and the exterior part. And our basis for that would be the two lines being cut by the transversal. So the ones inside are what we call the interior part, and the ones outside, the upper portion of this line and the lower portion of this line, is what we call the exterior region. So an angle that you see on those regions, let's say 3, 4, 5, and 6, they belong inside, so they're interior points. And 1, 2, 7, and 8 are exterior points because you see them in the exterior region. So there you go. We can already answer the sample problem that we have here. Angle 1, that is in the upper part of our line. That means it's an exterior point. Angle 2 is also an exterior point because it's in the upper portion of our line. And angle 3, since it's inside, it's interior. It's an interior angle. Angle 4 is also in the interior part, so it's interior. It's an interior point. I mean angle. And angle 5 is also an interior angle. Same with 6. And the ones below this line belongs to the exterior region. That means 7 and 8 are both exterior. Now, let us try to look into um, angles on the same side. So our basis when we say that two angles are on the same side will be based from the transversal. So which is our transversal here? So this one. This is our transversal. So this is line T. So commonly it's so called as line T because the first letter of the word transversal is letter T. So now, let's answer one. Angle 1 and angle 2, are the two angles on the same side based from the transversal? So notice that 1 is on the left part of our transversal, 2 is on the right side. So that means they're not on the same side. How about 2 and 6? Angles 2 and 6. So notice that angle 2 is on the left of the transversal. I mean the right part of our transversal. Same with 6. They're both on the right side. In other words, that's a yes. That's how we determine if two angles are on the same side. You just have to base it from the transversal itself. How about 3 and 6? Angles 3 and 6. 3 and 6 are here. Okay, angle 3 is on the left side of our transversal. 6 is on the right. So the answer is no. Okay, how about 4 and 8? Angles 4 and 8 are both on the same side, the right side of our transversal. So that's a yes. How about angle 5 and angle 1? Both of them are on the left side of our transversal. So that's a yes. And angle 6. How about angles 6 and 7? Okay, angle 6 is on the right side of a transversal and 7 is on the left side. So that is a no. How about angles 7 and 1? It's on the left side of the transversal, This one is on the left side as well. So therefore, that's a yes. And angles 8 and 3, 8 is on the right side of a transversal. Angle 3 is on the left side of our transversal. That means that's a no. So now, the next set of angle pairs are actually possible because they are lines being cut by a transversal. So in other words, the angle pairs that I will be discussing to you would only be applicable if there are two lines or more lines being cut by a transversal. So the first angle pair formed when lines are cut by transversal would be corresponding angles. So here are some examples. Angles 2 and 6, angles 3 and 7, angles 1 and 5, and angles 4 and 8. These are four examples of corresponding angles. And again, these are also angle pairs, so that means two angles at a time only. Okay, so this time, I want you to figure out the best way to identify whether two angles are corresponding. Okay, so let's discuss. There are actually three things that you have to remember when we talk about corresponding angles. So first of all, they are non-adjacent. So I hope you remember how do we identify two angles that are adjacent from our previous lesson. Okay, next checklist, they should be on the same side of our transversal. Okay, so let's consider angles 2 and 6. So angles 2 and 6 are here. So take note, non-adjacent, they don't have a common vertex. This is the vertex of angle 2. This is the vertex of angle 6. So, they are non-adjacent. Next, on the same side of the transversal, they're both on the right side of our transversal line. And finally, take note that one is exterior and the other one must be interior. So looking at the given, angle 2 is exterior. So it's in the upper part of the line. And then 6 is interior. So if that happens, then they are corresponding angles. Okay, the next one or the second one is what we call the alternate interior angles. So we have here angles 3 and 6 as an example, and another example as angles 4 and 5. So pause this video and try to figure out how to identify whether the two angles are alternate interior angles. Okay, that's right. When we talk about alternate interior angles, still, they are non-adjacent, but interior angles. So non-adjacent, and then both are non-adjacent interior angles. And then at the same time, based from a transversal, they must be in opposite sides. So let's verify an example. So angles 3 and 6 are here. So notice that they are non-adjacent again because the vertices are here. And they don't share a common vertex. Next, interior angles. So notice that 3 and 6 are both inside the two lines that we have here. So, interior angles. Then must be on opposite sides. Angle 3 is on the left, angle 6 is on the right. So that makes alternate interior angles. The next one, or the third one, is what we call the same side interior angles. So we have here two examples for you to be guided on how to easily define or identify whether angles are same side interior angles. Okay, so that's good. So how do we identify same side interior angles? So very simple. So take note that the two interior angles are on the same side of the transversal. So first, both must be interior. Then don't forget, same side. So let's see the example. Angles 4 and 6 are same side interior angles. So from the name itself, interior, it must be inside, which is 2. And finally, um, it should be on the same side. So this is our transversal again. Then they're both on the right side of our transversal. And that's how you identify whether two angles are same side interior angles. Now, let's talk about alternate exterior angles. So we have here examples again, and I want you to pause this video and figure out how to easily identify alternate exterior angles based on your own. Okay, so by now, I assume that you have your answer, but the checklist would be first, non-adjacent, and next, both are exterior angles, points that you see outside, and opposite sides of transversal. So those are the three checklists. So let's take an example. Let's say angles 7 and angles 2 and 7. So angle 2 is here, 7 is here. So notice that they're non-adjacent. Because the vertex of angle 7 is here, vertex of angle 2 is here. Now, both must be exterior. So this is the upper part, and that includes the 2. This is the lower part, which includes the 7. Then, finally, opposite sides of transversal. So, the angle 2 is on the right, angle 7 is on the left. Okay, so there you go. You have corresponding angles, alternate interior angles, same side interior angles, and alternate exterior angles. So how can we relate these angle pairs form when lines are cut by a transversal in real life? So first, windows. So we see two lines. Those are the two lines cut by a transversal. Bridges or skyways. So it also happens that um, that there are two lines here that are being cut by a transversal. So the transversal is this portion. And then you have the two lines with you. Roads, yes, that's true. These are the two lines a while ago. So lines. Then finally, the ones that crosses both would be a transversal. So to find A, there's actually a lot of ways, but the best way for me is to figure out that angle with the measurement 130 degrees and the A are both what? Again, the angle with 130 degrees and A are both, okay, that's right. These are alternate exterior. Now, in the fence as well, you see lines cut by transversal. Instructions. Name the pairs of the following angles formed by a transversal. So, there are two angles here. Angle BPQ and angle DQP. So, the relationship between the two angle pairs here, they're both alternate interior angles. So, first, they're non-adjacent. That's true. They have different vertices. Alternate. One is um, one is on the right side of our transversal. One is on the left side. So we call that as alternate. Then interior, both are in the interior part or region of our two lines, cut by transversal. Alternate interior angles. Okay, how about this? We have angle PQD and angle GPA. Okay, that's right. The answer is corresponding angles. So how come they're corresponding angles? So first, non-adjacent. They don't have common vertex. Next, um, same side. Based on the transversal, both are on the left part of our transversal. So, same side. Then lastly, one is interior. This is the interior angle. And then this one is our exterior. That means the two angles here are corresponding angles. Okay. How about this example? So you have angle APQ and here we have angle DQP. Okay, that's right. Same side interior angles. So why same side interior angles? From the title itself, same side. Both of the angles given are on the left side of our transversal. Then interior, because both angles are in the inner portion of our lines, cut by a transversal. Now, just a quick review. What would you call two lines which do not intersect? So we call them as parallel lines. Now, the easiest way to deliver a message that the lines are parallel, we can actually use an arrowhead. Just have to put it in between the line and make sure that they have the same number of arrowheads. If they do, that means that the lines are parallel. So, when two lines are parallel, we use this symbol as an indicator that the two lines being mentioned are parallel. So, an example for this one, line AB, this is line AB. I repeat, this is line AB. So, let me just use an highlighter for that. This is line AB. And based from the given, this symbol again is pertaining to parallel. By the way, to read this is just line AB is parallel to line CD. And to go back, the other line is here. So line CD. So we're saying that the two lines here are parallel. It's either you're just given with the illustration but you see arrowheads in between them and same number of arrowheads, or it's given that the two lines are parallel. Now, let's try to observe this video as we try to figure out um, the relationship in terms of the measurement of our two corresponding angles. So as you can see here, there are two lines being created by the person. Then let's say this is line L, or line L sub 1, or this is line sub 2. So afterwards, let's try to create a transversal that cuts the two lines, lines 1 and 2. So the name of our line would be the transversal. And then, okay, if you try to identify two angles here that are corresponding, these are corresponding angles. And then if you try to cut them out, and if you put angle 1 on top of angle 2, you will notice that it fits in completely. In other words, what can we conclude if two angles are corresponding? They are congruent. So based from that activity, we're able to figure out that they are congruent. But only if, there's a condition, only if the lines cut by the transversal are parallel. So I repeat, it's very important to remember that before you conclude this, you will be able to identify that the lines are really parallel. So, with that, we can already answer here um, the problem based from what we already know. So, first, angle 1 is 120 degrees. So, that's a given. So, let's start with angle 2. So, angle 2 is what? Angle 2 is 60 degrees. Why? Because the relationship between angle 1 and 2, let me just write down so that you will have your notes with you. Angles 1 and angle 2 are what? They form a linear pair. And linear pair are adjacent angles and supplementary angles. So so it's expected that when you add the measurement of angles 1 and 2, it must be 180. So to get angle 2, 180 minus 120, you'll get 60. How about angle 3? Okay, now with angles 2 and 3, you can easily determine that these are vertical angles. And we have discussed this before, vertical angles are always congruent. So if this is 60, angle 3 must also be 60. And same with angle 4, similar concept. When we compare angles 1 and angle 4, they're also vertical angles. But of course, there's nothing wrong if you consider 2 and 4 as the pairing. Angles 2 and angle 4, they form a linear pair. So now, how about angle 5? Angle 5 is 120 as well. So why? Because angles 1 and 5 are what? They are, these are corresponding angles. And ano yung nasabi natin sa previous natin na activity? Corresponding angles are congruent, but only if there's a guarantee that the lines cut by transversal are parallel. So for now, there's a guarantee because of one arrowhead per line. So that means if angle 1 is 120 degrees, angle 5 must also be 120 degrees. Again, this is only true if the lines are parallel. So same concept. 5 and 6, this 6 is 60 degrees because they form a linear pair. So 180 minus 120, 60. 7 is also 60 degrees. Then angle 8, 120 degrees because 5 and 8 are vertical angles. Same with 6 and 7, these are also vertical angles. Now, to sum up all the possible angle relationship, okay, we have here a list. But remember, this is only applicable when the lines are parallel. So that's why it's so called a special angle relationship because it's only true to some cases. So don't forget the interior, the exterior, and the same side, and they alternate. So when two angles are alternate interior angles, then that means they are congruent angles. And that's also true to alternate exterior. They're also congruent no matter what. So just like 1 and 8, angles 1 and 8 are alternate exterior angles. Alternate interior angles are 3 and 6. Same with 4 and 5. Now, same side interior angles are supplementary as well. So, example, 4 and 6, um, they go together and it must sum up to 180 degrees. So, lagi natin tatandaan kasi ito yung parang common mistake. These special angle relationship happens only if the lines are parallel. So let's try to practice. So find the measure of angles 1 and angle 2, and angle 1 and 2, and explain your reasoning. So there's a guarantee that lines are parallel because of the arrowheads. Okay, now with angle 1, so we need to compare it with this angle. So what's the relationship between the two angle measurements? These are corresponding angles. So take note, this is the interior area or region. Then exterior yung may 110. So 1 interior, 1 exterior. Then that's it. So angle 1, the measurement of angle 1 is equal to 110 because corresponding angles are always congruent. But I repeat, only if the lines cut by transversal are parallel. And finally, the measurement of angle 2 is also 110 degrees. By the way, don't forget that vertical angles are always congruent. Next, we have here angle 1 and angle 2. And there's a guarantee that the lines are parallel. So, with that, um, angle 1 and the angle with 65 degrees, they form a linear pair. So that means, to simply find angle 1, when you add them, it must be equal to 180 degrees. So you have to add negative 65 in both sides. Then the measurement of angle 1 is equal to 115 degrees. Okay, then angle 2. Okay, so take note the relationship now of angles. Ano ba yun? Angles 1 and 2. These are alternate exterior angles. Okay, so that means um, angles 1 and angle 2, these are alternate exterior. So in other words, alternate exterior angles, um, okay, that means that the measurement of angle 2 is also 115 degrees, knowing that alternate exterior angles are expected to be congruent. Now let's proceed to the next one. So we have here A and B and we're asked to figure it out. So perhaps you might want to consider comparing the angle with 115 degrees and the A. So they're both, okay, they are both, they form a linear pair. And linear pair, they're supposed to be supplementary as well. So it's expected that when you add 115, it should result to 180. So ito yung step 1 natin. So add tayo ng negative 115 sa both sides. So that's 180 minus 115, you'll get 65. And since you know that what is A already, so actually there's a lot of way, but in my end, I'll use B minus 15 and the ones with 115 degrees. So, unang-una sa lahat, you will see that they're non-adjacent. Then, one is interior, is exterior. And they're both on the same side of the transversal. So in other words, these are corresponding angles. So B minus 15 must be equal to 115 because they're expected to be equal. So add 15 in both sides. So B is 130. Okay, how about this? So notice that we cannot just simply pair up A and 2B minus 25 because there are two variables involved. So, safest one is you choose someone with similar observation. So the 2B minus 25 in here is an exterior angle, B is one interior. Both are on the same side. So therefore, 2B minus 25 and B are corresponding angles. And corresponding angles are equal. So 2B minus 25 is equal to B. So to isolate the B here, add 25 first. So you will get 2B is equal to, okay, this will become B plus 25. Then, then I have to add negative b in both sides. 2b plus negative b is b, 0, then 25. So that's b. How about a? So notice that angle A and angle B are same side interior angles. Okay. In other words, remember that same side interior angles are also supplement supplementary. So this is our next solution. Adding A and B must be equal to 180. Okay? So, okay, we know that angle B, we got 25. So we just have to change it with 25. Then afterwards, you add negative 25 in both sides. So angle A is what? 180 plus negative 25 is 155. So ayan, we have for A, we have for B. So we have here another example where asked to find the x. So just an x. So in other words, we look into the two angle measurements here. And it's given that as well that these lines are parallel. So if you extend that, you will notice that these are should become lines. And then notice that this is your transversal. And then this part, just don't mind this. You will see two lines cut by a transversal. Then the two lines, there's a guarantee that they are parallel. So in other words, you just have to look into the relationship between the two angles in here. And these are corresponding angles. So this is the exterior, interior. Then on the same side, on the right side of our transversal. So, corresponding angles are congruent only if two lines cut by transversal are parallel. So x plus 33 is equal to 2x minus 3. So perhaps I wanted to isolate the x on the left. So this 2x here on the right must be completely be removed here. So add negative 2x in both sides. So x was negative 2x is negative x. Bring down 0, then negative 3. And finally, to get rid of this 33, which doesn't have a variable x, add its opposite. So you will get negative x. This is negative 36. Then both are negative. So we can divide both sides by negative 1. So x is equal to 36. So this is the answer. Okay, how about this? So first, it's given that these lines are parallel. So when you extend that, so it will show us that there are two lines here. And this part is the transversal. So, what's the relationship between the angle with 12x and 6x? Okay, they are both are what? They are, oops, same side, interior angles. Okay, why? Because they are on the same side of the transversal. Both are on the left part of it. And then, at the same time, interior angles. That's why it's interior. So, since same side interior angles are always supplementary. So when you add them, expected to be 180. So 12x plus 6x, that's 18x. And you divide both sides by 18, so you will get 10, or like this. So you will get x is equal to 10. So we're not yet done because we still don't know what is y. So in terms of y, because this is our initial step, second step is we simply consider as these two lines. Then this would be our transversal. So what's the relationship between 4y and 6x now? They're also same side interior angles. Same side of the transversal, the ones on top, and then both are interior angles. So same side interior angles. So 4y plus 6x must be equal to 180. We know that you already know what's x, so you can simply substitute. So 6 times 10, that would be 60. So let's continue here. So you need to add negative 60. So 180 minus 60 is 120. Then we divide both sides by 4 or multiply both sides with 1/4. So that's 120 divided by 4, you'll get 30. So y is 30, x is 10. Okay, now, so we're asked to find all the missing angle measures given that ito lang yung binigay na angle measurement. So first, we know that this angle and the angle here are, okay, both angles here, this and this. Vertical angles are always congruent. So if this is 120, this is also 120. Then finally, they form a linear pair in here. So it must be 180. So 120 minus 60. So that would mean 60 as well. So this angle here and here. So if this is 60, this must also be 60. Okay, so if this is 60, let me just erase this so that you can see it clearly. Next is that, okay, This is also 60 because remember, there's a guarantee that the lines here are parallel. And this angle measurement here with 60 degrees and this part, they are corresponding angles. Corresponding angles are congruent. So if this is 60, this must also be 60. Then afterwards, you will notice that this angle and angle here, those are vertical angles and they're congruent. So if this is 40, this is also 40. Okay, next, we know that this is already 60 degrees, right? So it's this is the vertical angle. So if this is 60, this is also 60. Then we can get this portion already. So how will we do that? So we know that this is a straight line. And then one straight line is 180 degrees. So you just have to add. So 40 plus 60 plus there is an unknown here, which I will name x. It should be equal to 180. So 40 plus 60, 100. Then add negative 100 in both sides. You will get x is equal to 80. So this is 80. This is also 80 because these are vertical angles and they're congruent. Okay. And then next, this is 80 degrees. So I will just tell you in advance. This is a triangle, right? So the sum of the interior angles must be 180. So to make it 180, so what you need is you get the sum of 40 and 60, that's 100. So added with the third one in which still unknown, it should result to 180. So there you go, naging 80 na siya. So vertical angles din sila. So this is also 80. They form a linear pair. So that's 100. Then 100 as well here. Because these are vertical angles. And that's it. So thank you so much for listening.